Hey guys, so this is the part 3 of sharing most important questions of data structure and algorithm for MAKAUT semester exam, third sem students, CSE or AIML or IT students. So here in this presentation, I am going to talk about the most important topic of DS, that is stack data structure. So the stack data structure is a linear data structure that accompanies a principle known as LIFO principle, last in, first out. And the real life example of stack are deck of cards, piles of books, or piles of money, and many more. So this is the visual representation of stack data structure, where at initially, that means uh, at the last point, it that is called the top value of the stack, that is -1. That means initially when we are here at the index 0, the value of the top is -1, and here total five five parts are there in this stack. And in stack there are mainly two or four operations we can perform, like push operation, pop operation. Push function or push operation means insert an element at top plus one position of the stack. That means initially the top position is -1. That means here initially the top position is -1. That means at this position. But when we try to push and or insert an element in the stack, then we will increase this top value by 1, and then we can insert our new elements here in the zeroth index. And this pop or delete is an element from top position of the stack. That means we can only delete any element from the top of the stack. That's why this is LIFO principle, right? That means what is inserted at the last will be eliminated first, will be popped out first. That's why this is the LIFO principle and this is called stack. When top is equal to -1, that means there is no element in the stack, and this condition is known as stack underflow condition. In this condition, if we execute pop operation, then print stack will be empty. Then the stack will be empty. When top is equal to maximum -1 means the stack is overflow. Maximum is 4 and maximum number is 5. So 5 minus 1 means 4, and as the index is 0, so 5 minus 1 will be the last position. That's why in this position stack cannot enter any more elements in this stack. That's why this condition is known as the stack overflow condition. In this condition, we execute push operation, then it will be print as overflow or the stack is full. So operation 1, push 5. We have to push 5. This element is 5. We have to push 5. So now top is equal to top plus 1. So initially top is equal to -1, and we perform top is equal to top plus 1. That means the top is as 0 position. So at this position 5 will be inserted. Next, operation 2, push 60. So the top, then we have to perform top is equal to top plus 1. So currently top is at 0th position. Now we have to increase top by 1. So at 1st position we can insert this 60. Next operation is push 7. So now the top will be increased by 1, and in this position we can insert 7. Likewise, For operation 4, push 10. So the value of top will be increased from here to here, and in this position we can insert push. Sorry, we can insert 4. Likewise, for push 100, we will be increasing top value from here to here, and then in this position we will be inserted this 100 value. Now push 50. When the top is at 4 position, that means top is equal to maximum minus 1, where the maximum size of the array is 5. So now the stack overflow condition is matched. So this will be overflowed. This will print the overflow, that the stack is overflowed. Now we have to perform the pop operation because already the stack is full. We cannot perform any more the push operation. So we have to perform this pop operation. So from here at the last, because it is following the LIFO principle, stack is following the LIFO principle. That's why we can pop from here. So the top value will be decreased by 1, and now the top pointer is pointing at third index, and this 100 will be popped out. You can see here, now the top value is pointing here and the 100 is popped out. Likewise, if we again do the pop operation, then the top value pointer will be here, and again this this 10 value will be popped out, and it will be print 10. Again, if you do the pop operation, then the top value will be decreased by 1, and top will be pointing here like this. Now top is equal to minus 1. Again, if we perform this pop operation, then it will show that the stack is empty because top is equal to minus 1. So now the stack is underflow. Stack can be used to check the validity of parentheses in any algebraic expression, like this. If the bracket is open, then the bracket should be closed. For example, you can see this is the second bracket or third bracket, and these are. This is also valid because all the opened brackets are closed, but this is not valid because here one, two, three open brackets are there, but only four open brackets are there, but only three closing bracket are there. That's why this is not valid. So here, this is our input and this is our stack. And the first step is checking. Check if the input 0th position is equal to opening bracket or not. If yes, then push that element inside the stack. So here this is the opening bracket, so we are pushing inside the stack. And our step 2 is check input 1 at 1st position, it is opening bracket or not. If yes, then push the opening bracket into the stack. We are pushing this bracket here. And the third step is opening bracket at the second index, the opening it is also an opening bracket or not. If yes, then push the opening bracket into the stack. Same before. Step 4, we are again checking that it is an opening bracket or not. Here it is an opening bracket, so we are pushing inside the stack. Step 5, if it is a closing bracket, if yes, then compare the pop item, then compare the pop item from the stack with input 4. If both the bracket are same pattern, then go to next step. Otherwise, we say that it is not valid expression. Here, pop item from stack is this. The pop item from the stack is this, and both are same pattern. We are going to push this this is the closing parenthesis and this is the opening parenthesis. So this is these both are the same pattern. So we can pop out these two easily. Now, what is the step 6? That step 6 says that the if again we encounter any closing bracket, and here this is curly bracket or second bracket. We are encountering a closing curly bracket. So we and both the same pattern. So we can easily pop out and decrease the value of top pointer. Next, we are encountering a opening bracket, opening parenthesis. So we will be inserting inside the stack. But here we are getting a closing parenthesis bracket. That's why we'll be popping out. Then this is also a closing, curly bracket. So we'll be pop this also. Now the top will be at this position, and at the last, the step 10, we will be popping this 2. So the top will be at now initially position, that means -1 position. Simple. Now for this, I'm not going to explain this again. Please positively watch this animation. I wish you could understand very easily. Here in this stack, one expression is present. There is no element in the input array. There is no element in the input array, but still stack is not empty. And that means the expression is not valid. For case 3, watch this animation very carefully and try to understand or try to do it by yourself. So thank you students. Thank you for watching this video, and please do like, share and subscribe to our channel. And if you are not subscribing, then it will be very hard for you to find out our next upcoming video of this playlist. So thank you so much.